Hi, everyone, and welcome to our webinar on how to streamline your workflow from survey design to deliverables with Geoscience Analyst, presented by Thomas Campagne, Senior Geophysicist at Mira Geoscience. Before we begin, I'd like to remind you that this webinar is being recorded, and I think that's it. So you can go ahead, Thomas.
Well, thanks, Carla, and welcome everyone to today's webinar. As Carla just introduced, we're going to go through a workflow to show you how to go from importing data, designing a survey, applying QA, QC, and data processing to this data, and then to wrap everything up by generating deliverables you can share with your peers and clients. So just to maximize screen space, we're just going to turn off our videos and just keep the audio, and I'll get to share my screen further. All right, so let's get started. Now I'm sharing with you Geoscience Analyst. So it's a visualization and modeling platform. So very standard here for those of you that are not familiar with it. On the left, we've got an object tree with already some objects loaded in today's workspace. We've got our 3D viewport here in the center. We've got some other data colors and visual parameters tabs here on the right. And on the lower, we've got panels with metadata, object properties, and data tables of the selected objects. So to get started, what I like is just to bring a bit of context about what we're going to do today and where we're going to do it. And I've already got a saved view that I'm going to share with you. And so I'm going to view menus, general view, which is the view that I named. So today we're going to use magnetic data. I'm trying to design a survey for a magnetic survey in the Golden Triangle of British Columbia. And we'll use public data published by Geoscience BC through their Golden Triangle compilation project. So you can see here, we've got the map from the project. We've got a little label here showing us where I will be working today. And if I select the actual object, which is the georeference image here, you can see in the lower right, I've got some files attached to it, like the report from this project. So I can just double click on the PDF and it just pops up. So just something to keep in mind that you can share it with Geoscience Analyst and the object stored in the object tree. You can attach a variety of files to them. What I want to do first now is to actually bring in data. So I'm just bringing here my file browser, and I'll bring a shapefile for the AOI. I'll bring a DEM raster. I'll bring permanent snow and ice outlines, satellite georeference image, the toporama, topographic raster image, and water linear flow. So that's the river. So I select all these files, drag and drop them into the viewer, and the import is just done for all of them in sequence. Perfect. So I'm going to turn off the label and the large map here. And now we've got all the rasters and the shapefiles that were imported here. So for all the polygon shapefiles, they will import as a surface and as the polyline surrounding the surface. So for the AOI here, for the permanent snow and ice, we've got this as well. And we can just give the AOI, just a stronger color here, red, permanent water linear flow. Let's just give this a deeper blue. Perfect. And this guy's here, like a lighter icy blue. Perfect. So that's for to note as well is that everything is loaded at constant elevation, and we'll see to that shortly. Now, for the raster imports, you can see that every single raster has been imported as an image, georeference rendered image, and as a 2D grid. So in terms of the DEM, we've got here, I'll just them all. We've got the rendered image of the DEM, which is a one-band geotiff. And on the 2D grid, we have the actual 2D grid with the property on it. If we're loading a satellite image here, so it's already a rendered image. We've got a corresponding 2D grid with the RGB and alpha channel bands, or for the case of the toporama topographic raster, we've got just the RGB channels here, which can be useful to have as well. One of the first things I'm going to do is to go back to our DEM, and I'll be extracting the DEM surface. To already bring things into a true 3D. So I'm right-clicking on the grid, looking for create, and I'll go for surface from data. Perfect. Let's select the DEM property, and I'll name that DEM surface. There we go. Now I've got the DEM surface here, which is already quite useful to get acquainted with a new area. We can actually paint an image on it. So I'll just put this satellite image. So you can see now, got a bit more context about things. And before we're looking at these things here, our rivers, ice outlines, and the AOI, and we can actually better kind of like modify that. So I'll go to my utilities, go to translate, and I'm going to first relocate the AOI polyline to be generally above topography. Perfect. It's not cutting topography anymore. It's visually better. And what I can do to follow that up, I can actually choose to drape. So I'm right-clicking on the object I want to drape, and I will drape permanent snow and ice and water linear flow. So two objects at once onto my DEM. It's going to take a bit of time here. Here we go. So now I've got my rivers and ice or glacier outlines draped on topography. So it's fairly interactive, and we can better assess, the terrain where the survey is going to be flown. So now that I've imported this data, I've compiled something. I'm going to move on to the survey design. So I'm going to do that. I'm going to remove the DEM surface. Go on a top view here, and I can save that top view for future reference just by creating a new view. There we go. So I can actually just go back to general top view. So now I'm going to design a survey, and I'm going to trying to recreate the existing and the flown survey lines. So I'm going into the panel menu, and I'll select Survey Designer. So it just popped here on the right, my Survey Designer. I'll select Airborne Magnetics. I'll design a new survey. I can add a label to it, which is just a text label. So I'll choose helicopter. And I'm going to actually pick a specific origin and settings here to build my survey because I want to really fit the flow line. So here is an origin. The angle of the survey is 6.4 degrees. I want to just set the station spacing at 100 meters for now. And you can see there's already a line that starts to form here. I want to have 79 lines, 100-meter line spacing, perfect. I want the length of my lines to be at 7,400. Here we go. So we can see I zoom in. You can see our lines here being created dynamically as I put the data in. Tie line spacing at 2,000 meters with an offset of 260 meters. So you can see in here, you can see the tie lines, the stations, and the flight lines. I can also drape this on topography. So that's the average ground clearance of the phone survey, and select my DEM surface. There we go. So here we've got already our lines, our flight lines. Right now, stations are just 100 meters spaced along the lines. So I wanted something a bit more realistic. Just put like a 5-meter spacing. So it's going to take a bit of time to generate these additional nodes. And it's going to come shortly on the screen. Here we go. So now we've got, more reasonable sample spacing along the lines. And I can just wrap this up by clicking on Creating Survey, and this will create a new object here in my object tree. So I'll just add a group. I'll call, so a group or folder. called survey design, and I'll bring data in, and just gonna hide the nodes. Perfect. So here is the survey lines. So looking at a top view here with an orthometric top-down view, I can see that I've got chunks of lines still, portions of lines still going outside of the AOI. So I'm gonna show you how we can actually clip that. So I'll right-click on the lines. I'll go to create, and I'll create a masking property from a boundary curve. Select that closed curve, which is the AOI polyline, click on OK. And what this is doing is creating a masking property where all the nodes falling within the polyline will be valid, and all the nodes falling outside of it will be attributed with no data value. So if I turn on this property, you can see this is what falling within the mask. And I can use that to actually clip the unwanted portions of lines. So I'll right-click on the object, go to create, and select object from masking property. Perfect. So I've got that new object created here, just hide the nodes, just store it here. Rename it. Perfect. And now, if we just look at what we had before. So that was the lines previously, and now that I've clipped them, retain only the portions of lines within our AOI. So now what we can do to further refine our survey design, it's quite interesting to also do a sensitivity analysis. In some cases, we have an idealized target, and we want to see if we're able to actually image it with the survey we're designing. And you can quickly do that by forward modeling the response of a synthetic target. To do that, we first need to build a block model. So I'm going to Utilities, Block Model Designer. I select a reference object here, which is my clipped survey. I click on the light bulb, and you can see as I do so, it already shows me the block model that I'm building. So I'm just going to have something quite coarse here with 100-meter cell size. So as I'm doing this, you can see cell size is increasing. And then I don't want expanding cell size. I just want a pure block model with just blocks everywhere. Block model for evaluation. Here we go. And I create this block model. Now, on this block model, it's an empty mesh, an empty object. I will create a background property that has just a background low susceptibility. So I'll use a script, and I'll name it sus eval, and I'll put that property at a very low value here in SI units. Perfect. So now I've got that property, it's just everywhere. Right? Now on that block model, I can right-click on it, go to create, and I can actually discretize shapes. And here, I'll be able to discretize a variety of shapes from spheroid, ellipsoid, cylinder, rectangle, and cone. So I'll do an ellipsoid today. I'll just put it somewhere here in the middle with a 30-degree dip, 30-degree azimuth, 1,000 here, 2,500. So you can see as I do it, I can actually just see the shape I'm building here. I will give it a value, let's say 50 milli-SI, so 0.05. Click on OK. And now I actually burned that property here. So I've got a block model with a synthetic target. And now I can go to the geophysics menu and compute forward model. Select magnetic for the type of forward modeling. We can select our points here. I'll need to input the field strength and ambient field parameters here. I can select our topography surface, our 3D model, and the specific property, and just compute the forward model. So we're not going to do that live right now, but that's how you would actually compute the response of this ellipsoid onto your data points and assess the response of that body. So now that we've run through the survey design, let's go into the QA/QC and processing portion of this webinar. And to do that, I will bring in the actual flown lines. So they were delivered as a GDB from in a GeoSoft format, and just drag and drop into Geoscience Analyst. So this brings this window here where we can pick the location channels here, X, Y, Z. I can select the lines that I want. So I could actually toggle off the timelines if I didn't want them. And here all the database channels as well. So let's click on OK. And this will import the database. Perfect. So I'll just rename that as survey flown. Perfect. I want to see the nodes. So we can already, first thing is to actually compare, give it a darker color here, dark gray, perfect. Compare our flown survey with the actual flight lines. So we can go at a top view, top down, and we can assess, actual deviations from the lines visually. What we can also do is go into the 3D and assess like the vertical mismatch between the synthetic and flown lines. And we can see here it was quite a tough topography to follow. So the flown lines in dark green are quite higher up from the valley floor. Right now, we don't have tools to quantify these deviations, but they'll be, we're working on it, and I'll come in future releases. So another thing that can be done from onto the imported database is that if we have raw data that were not actually despiked, we would be able to go to processing in the geophysics menu and apply line filters to despike the data. So we'll select a curve here, and I could apply, a series of filters like median filters, moving average, Noddy, and Savitsky-Golay onto the lines. Right now, these data have already been despiked, so applying the filter will not, show us much today. Another thing that can be done to inspect the data is to use the 2D profile viewer. So I'll just turn this off here. Perfect. And I'll go to the 2D profile viewer panel, and I'll select GDB here. So you can see it's already showing me a profile. So it's the base mag that's being shown. We'll do mag 1. I'll do the fully processed data here. I can add a national graph with the radar. So we can actually, assess process channels, distance off the ground, and we can move from one line to the next. One thing that's interesting to know is that the 2D profile viewer is also linked to the 3D viewport. So if I were to select a point here, let's just say that anomaly here, you can see there's a yellow line here, and we've got that button toggled on that shows me the end of the lines. If I go back to my viewport, I can see that that's the line I'm looking at, and that's the point I've picked. So if I go back to my profile viewer, select another line, and I pick this, I go back to my viewport, it's this line and this point here that I'm looking at. So there's that interactivity between the profile viewer and the viewport that can be quite useful to go through your data. One thing that we've noticed with this data is that they're not IGRF corrected. So here I'm looking at the MAC 3. So it's the level data, just going to actually arrange a little bit the colors. Perfect. So they've not been IGRF corrected. So we're going to actually do that. First, if I look at the data and the metadata of the lines, there is no coordinate system information. So we'll first need to actually add this. So I'll specify the coordinate system. There we go. So I can go in here, type UTM, try to look through the menus, or I can actually directly put the UTM, the EPSG code. So perfect, of the projection. So do that. And now in my metadata, I've got the projection information here. I can then right-click on my survey lines and go to Compute 13th Generation IGRF. So I've already selected the object. The survey was flown in 2017 in May, and the midpoint of the survey is May 8th. I select the magnetic data here as Mag 3, perfect. And I'll just click on OK. And this will create two new properties on my object. So here, looking at the top view, we've got the IGRF property that's computed at every single point location in 3D. And we've got the Mag 3 where the IGRF has been removed. So that's the residual magnetic data, and I can name that, quickly, Mag 4. So from there, one other thing to note is that the IGRF average parameters for the whole survey have been stored as metadata on the object as well. We'll get back to that later. Now, the next step that I want to do is to actually prepare these lines for interpolation onto a 2D grid. And one thing that might be an issue is the mismatch between the tile lines and the traverse lines. So what I'm going to do is to actually remove these tile lines. So I'm going to show you the line ID here, looking at the top view. Perfect. And now for the data color of the line ID property, you can see here I've got all the classes for every single line. And if I scroll down, I can see these eye logos. I can just toggle off the tile lines. And now I'm only showing the traverse lines. And I can create a mask based on this. So I right-click on the object, go to Create, Masking Property, and I can create a masking property from Visible Association, Non-Visible, or Selected Indices, or Non-Selected Indices. So I'll select Visible Association, and I'll name that mask Traverse. So now, if I just have all my object here, or my points, I select the traverse mask. I can see now that on this mask, all the points on the traverse lines are good, and all the ones on the tile lines just have a no data value. And I can apply that to existing properties here. So I'm going to create just a property for the sensor elevation quickly. GPSZ, there we go. And I can right-click on that property and apply mask to it. So now I've got the property with and without the tile lines. Same with Mag 3 and Mag 4. Perfect. So now on Mag 4, I've got with and without the tile lines. So from there, I can move on to my 2D gridding. To do that, I'll go to Utilities and select 2D Grid Designer. Okay, it brings me this window. I can select my lines here. I click on the light bulb. You can see there is already kind of like an idea of the grid that's shown here to give me an idea of what I'm building. I'm just going to lower this a little bit so I get a little bit of buffer around it. There we go. Perfect. And I'm going to extend that to, there we go. And here. Perfect. So we got like a little bit of buffer around the lines. The cell size, I put that at 25 meter. And I'll name that grid object grid 25 meter. Create it. So now I've got that grid. Just rearrange here. And that grid just is an empty mesh. There is like no data on it. So what I'm going to do now, and then after the grid, I'm going to actually interpolate the data using minimum curvature. So I'm going to Utilities, Minimum Curvature Gridding. Select, I can go through the menu here, Source Object, I can just pick it, and I'll select GPS Traverse, Mag 3 Traverse, and 4 Traverse. And I'll add an extrapolation distance here at 400 meters. Okay. So this will actually interpolate all 3 properties onto the grid. Perfect. I can turn off the lines. So you can see here I've got the GPSZ, I got Mag 3, and I got Mag 4 traverse here interpolated on the grid. And you can see due to the extrapolation distance, we actually bled like further than the actual footprint of the survey. And so as we've done before, we can use a mask to correct this. So create a masking from boundary curve. Perfect. So here's the AY mask, and I'll apply that mask. You can see here, I'll apply that to my properties here. Perfect. So you can see before, after, we'll clip that. So one specificity here in Geoscience Analyst is that on all objects, you can have multiple properties sitting on them. So you don't need to have like one grid per property. So, and that has its advantages as well. So now that we've got our MAC4 that's been clipped, I can actually apply to the grid filters on it. So I'll go to the geophysics menu, processing, so we can use that grid to implement an Euler deconvolution, but I'm going to apply Fourier filters on that grid as well now. I also want to point out that we can also on the database, we could do the base station drift correction as well on the lines when we import the data. So let's go here, Fourier filters, 2D grids. So the first filter I want to do is a reduction to the pole on MAC4, perfect. And I'm going to get the inclination and declination from these IGRF metadata on the phone lines. So here's my declination. So I'll just copy it through the keyboard shortcuts. Perfect. Inclination. Perfect. And just click on apply. So now I've got here in my object tree, we can see we've got a new RTP property. And on that RTP property, I can apply another filter. I'll choose the analytic signal because it requires different vertical or horizontal derivatives to be computed, and they'll be outputted as well. So I got more filters built in one. So I'll just select the RTP and click on OK. Perfect. So you can see here now on my grid object, I've got the analytic signal that has been computed. I'll just choose a slightly better color here. Perfect. The horizontal derivative. The horizontal derivative along north-south, and the vertical derivative as well. So all computed on the grid. One thing that we can do now is that grid is a kind of like flat object. So it's possible to actually transfer this back onto the lines to prepare our deliverables. To do that, I will go to Utilities and Transfer Data. So we can transfer data in Geoscience ANALYST from one object to another using this tool. So I'll just bring this here so we can see on the object tree, we've got the flight lines with all the properties on it and our grid here. So source object is the grid, and I want to transfer the RTP analytic signal filters, and I want to transfer that onto the flight lines. Got OK. And now on my flight lines, I do have the RTP corrected, the analytic signal, and the horizontal derivatives, and the vertical derivative as well, transferred onto the lines. Another thing that can be done as well, it's we can implement grid merging as well. So for this, I'll just bring in a few shapefiles. So we got a few more polygons here, and a GeoSoft grid as well for a follow-up survey. Perfect. Just make that on the side here. So now looking at the top view, I'll just hide this. So we've got our flown lines and our grid here with MAC3 on it. Perfect. And then we've got that new GeoSoft grid here with MAC3 as well on it. And we can see that there is a little bit of an overlap here. So what we're going to do is to go into our geophysics menu, processing, and we've got merge data onto the grid. So I'll select one grid, I'll select other grid, and I'll put that onto a coarse 100-meter cell size grid output. And I'll just click on apply. And now I've got a new merge grid here. I'll just put that here with the merge data on it. And you can see there is a bit of extrapolation as well. So we can use the merged outline here to build a mask on it. Perfect. And I can apply that mask onto the data. There we go. So we clipped it now. All right. So we can actually just send that merged data set now. We've got that new grid. And so that's how we do the grid merging. So now that we've looked at the processing and how to generate these grids, we can also look into how we can actually run an inversion. So we'll already run the inversion, so we don't have to actually get you waiting while the inversion is running, but I'll just show you how this can be done. So here is a starting grid, just an empty 2D grid covering the area where we've got our flight lines here. All right. So what we want to grid onto this, we can transfer the data. So we'll go into transfer data, and I'll transfer the data from the 25-meter grid here. So I want the Mach 3 traverse and the GPS-Z traverse onto my new grid here. So now on my unconstrained 100-meter grid, I've got GPS-Z and Mach 3. So it's still a flat object. And this is done because on that, I went from a 25-meter grid to a 100-meter grid resolution. So I can show you how we can downsample the data here. Now I can go right-click on that 100-meter grid, select Create, and Node from Cells. And I'll use the drape height or the elevation of the nodes here as GPS led. Click on OK. And now I've got downsample points here with bag on it. All right, so that's the way to kind of like downsample the survey. And now that we have this data, we have our DEM topography as well. We can actually build an unconstrained model by going to the geophysics menu, go to Compute Unconstrained Inversion. And here we can go there, select magnetics, observation points, select the data, put the uncertainty level here. If I wanted to, I can actually populate the field strength as well here. And there's a little trick, since I can use our flown lines here, so it populates the field strength, and I can just go back to my data. Perfect. Topography, DEM, the block model, that's the one I want to use, and I can just go here, click on OK, and run the unconstrained inversion. So to spare you some time, we're not going to run that here, and the model has already been run. So I can this. So here is the inverted model. So I can click on the object. There is a variety of things you can do to actually watch it. You can bring, the sections on it. We can bring the ISO values, where I can just play with the ISO values you can see here and threshold that. So I can put that at on 4 here, and also ISO surfaces here at 0.1. So right now it just displays it on the block model, but I can also now click on Create Surface, and it creates an independent surface object here at that threshold. So now that we also have our block model, we can further view the results in comparison to our flight lines. So if I go back to the profile viewer, I can add a section view to it, select our unconstrained inversion model and the model response. And now I'll be able to actually sample the inverted model right along the lines. So I can just go along and check the anomalies. Okay, this is quite interactive as well. Back to the viewport here. I can save a view as well here of this unconstrained model and decide that this is the view I really like. So I can go here and I can decide to add a view for F3 and I'll name that inversion. So now in my project, I can go from my general view to my AOI to my inversion model. So that's a workspace that can be shared already with people for, added interactivity between what you see and what you want your clients to see. So moving on now to generating deliverables. So there is a variety of things that can be done here. Everything in the object tree can be exported in a variety of ways. For polylines or points or surfaces, you can just right-click on the DEM surface to export, and we can export that as GXF, GoCAD format, CSV, data mine, and open mining format. So that's quite flexible here. For the polylines here, we can export that as shape files as well. So we got S3 shape files, Geosoft database as well. So there's a variety of options here. For the block model itself, we can export this as UBC GIF mesh files and model files, as a Leapfrog block model CSV format, pure CSV, and the open mining format, which is interactive with other 3D platforms. For the grids, where we add our filters, here we go. For this grid, we can export that in a variety of ways as well. So I can choose to export it as EarMapper, GeoTIFF, CSV file, and open mining format. For the GeoTIFF, it will export all the properties as separate bands for now. If I export it as an ERMapper format, which is a reflexible format that's supported by a wide array of mapping softwares or 3D platforms as well, we can just select output. And if I save it now, so it's a georeferenced raster format, it will actually export. So I can bring this here. I can export all the grids, all the properties here will be exported as a single independent file here. So in one go, I export everything. Another aspect of it is that if I want to actually export the analytic signal, let's say I'm really happy with how it's displayed. So I can click on grid and I can generate a rendered image from it. So create a geo image from RGB bands, no, single channel pictures. I'll select the channel here, which is the analytic signal, and I'll click on OK. So now I've got a new image here. It's just a georeferenced image, and I can decide to export it as a GeoTIFF. So now if I look at here, I got that GeoTIFF here. Just an image. The other aspect here is that on the flown data, as mentioned before, we can also add files to it. So I can just complete this compilation by adding the actual report. So I can just drag and drop the PDF report here. And now that PDF report will live into the compilation and is always accessible by anybody opening it. And that actually brings us to the end of this webinar. So I think I hope this gives you a good overview of what can be done and about a general workflow. And I'll just save the workspace now to wrap things up. And hopefully you found that useful, and we're looking forward to answer your questions. Thank you.
Yeah, so thank you, Thomas, and thanks to everyone who joined us today. If you have any questions, please type them into the Q&A panel. We would be very happy to answer them. And while you guys type those in, I'll mention that you're going to be receiving an email with a survey link asking for your feedback, which is really appreciated. It's also going to allow you to get in touch with us for more information. And finally, we're going to be emailing the recording to all the registrants in the next 24 to 48 hours. So let's see if there's any questions. Please comment on how you can export your results to GA Viewer.
Yes, I used Geoscience ANALYST Pro Geophysics for this demonstration, but when I saved my workspace, it was just saved into a Geoscience ANALYST GeoH5 file, and anyone with the viewer can open it. So that's how you can share everything with your clients. Everything that you see here, all the visual parameters can be updated through the viewer, and all the documents or files attached to the objects will be accessible to anyone with the viewer. So you're not limited to actually see the data and share that 3D knowledge and environment.
Another one here, is there anything for airborne TDM?
In terms of survey design, designing the lines would be pretty much the same as survey designer. But what you can do is to use into the geophysics panel here, you can actually use the EM field modeling tool, where you can choose a loop. Let's just use the AOI polyline here. So let's say that's my EM loop. It's not on the ground, but let's just go there. And my receivers are, let's just say, these points here. So unconstrained grid. So that's the points, and I can just compute the fields on it. And by doing this, now I'm looking at these points. So I've got the EM field parameters computed on it, and I can just use and now I've shown here the coupling, so I can see the EM primary field in 3D on my points. So this can be done also on the block model, and I hope that that answers your question. So if I was to do it on the block model here, the receiver, I'll just do this here. I know I've got all the primary field arrows here displayed on the block model.
Great. Another question is, when you exported the raster, was that single ERS files or one multiband?
So when I exported the raster, because on the grid, I have multiple properties, every single property will be exported as an individual ERS or ERMA per file. If you had just a grid with only one property on it, you'll end up with one file.
Yeah. How much did this require the geophysics package, the Pro Geophysics?
So all the survey designer is part of the Pro package. For geophysics, I think some of the key aspects of the processing here, like in the corrections, we can get back to you about this in more details. But yes, some of the gravity corrections and instruments drift or base station drift are part of the Pro package. But we'll get back to you with more details on this.
I believe the adding discretized shapes, the merging of the 2D grids, and then like Thomas was saying, some of those processing tools are part of ProGeophysics.
And the inversions as well. The unconstrained inversion, forward modeling and constrained inversions is part of the Pro package. But if we want to dive into constrained inversions or have more control on them, such as using VPMG or the SIMPEG package or GIF tools for the UBC codes, this is part of the Pro Geophysics package.
Yeah, will the recording be available and when? And yes, it will be. It will be sent to anyone that was registered in 24 to 48 hours. So you should be receiving an email with that later this week. Can we take a look at the statistical output of the inversion, please, and take a look at the tools for constraining it?
Statistical output of the inversion. So for this one, where we run the inversion, we've got, just got to turn up. So we got the block model at this point. So we've got, we don't have them here, but it comes, we've got the actual response, the residual, and then on the block model, in theory, there's a file that's attached to it with all the inversions, kind of like log and parameters that are saved. Here, it wasn't actually, we didn't keep it when preparing this webinar. Otherwise, when you run constraint inversions, so using VPMG, VPM1D, or SIMPEG or UBC, you will create an inversion object in which the input mesh, the data will be linked, as well as all the input and output parameters will be stored into that object. So as when you complete the inversion, you're able to capture the entire inversion workflow and the entire set of parameters and output information, so you can actually learn from it and copy that and duplicate that inversion and maybe tweak the parameters later on. So we really help you to keep that information, so you don't make the same inversion twice.
Great. I noticed that you merged the surveys. When you merged the surveys, the high mag response in the original survey became muted. Did you make a decision about what color range to use for the merged grid? For that, Thomas, I noticed you actually used you merged it with the Z property for the
Oh, did I?
grid.
Oh,
yeah.
Oh, my bad.
So I think
Sorry
that's why
that.
the colors came out looking a little bit weird.
Yeah, I went a bit too quick.
Yeah. But yeah, so did you make a decision about what color range to use for the merged grid?
The color range is done after. When you merge the grids together, you just end up with a new, like a merge property, and then it's up to you to choose a new color range, to choose the distribution of the data if you want histogram equalized or if you want it on a linear color scale. You can modify all that. You're not tied to a specific color range when you do the merging. And that's the same once you share that merge grid. Anyone opening with the free viewer will be able to change the color scales and the way the data are displayed without any issue.
Can you label points from a database?
Like as adding, you cannot add like the actual point value label to each of the points, but you can create, if you wanted to, let's say, here we've got on the flown lines, we've got the line ID here. You can see it's a different logo. It's a discrete property. You can actually create discrete properties of your own, where you would say, traverse or ties, or, this is kind of zone of alteration and so on. There is ways you can actually build new discrete properties where, you add these labels here. But otherwise, the only label you can show here is to, it's limited in that sense. Or I can actually just add a new label like this, and name this survey, and it's stored as a separate object in the object tree here.
I guess in the 2D profile viewer, you could also digitize points and
Indeed.
then add a comment to them. So that might be one way as well.
Yes. Yes.
Is there an educational package for universities? Yes, so we offer different licensing options depending on the size of the company or geological survey or university. So if you like us to send us more information on that, please feel free to get in contact with us.
And maybe one last question I can see about the maps for reports in the panels. We've got a map viewport, which is a top view where we can add. You've got a bit more control here, so I just added it. With grids. The scale. It's very. It's also a digitizing environment. It's a very basic map, and you can just save the image here. So and you can also turn off the logo for Pro and Pro Geophysics and save the image. So that's there is no proper map output in sense of having like the map key names and all that. You will be able to generate a 2D kind of map image that can be inserted in a report, but it won't be like a proper map, a PDF map.
Okay, we do have one more question, but well, we could do it. It's just one more. So you noticed that you're using 4.5 beta. What updates does this bring? And it's got tons of goodies.
Yes.
In the viewer, for example, you can now do hill shading on 2D grids. You can the draped models. So if you have like 2D seismic lines, for example, those are the performance of them is much better. It's very improved. You can create slicers using 1, 2, or 3 points. For Pro, there's a time animation UI that's pretty cool. Upgrades to exports and many other things here. There's a whole list. For Pro Geophysics, there's the line filters, Euler deconvolution, merging those 2D grids. There's EM options. The list goes on and on. There will be a proper there will be release loads with the new version. And I think that's it. Anything else? Don't hesitate to reach out. We're always available. And that's it.
Right. Thanks everyone for your patience, and I hope you found this useful. Bye-bye.
Bye. Have a good day.